This is Brian Murray. I want to welcome you to another episode of Doc Bry, the Physics Guy. Hey everyone, and welcome to this week's podcast. This week, we're going to talk about something that I reckon fascinates everyone to some degree. And it's one of the most accessible and least accessible subjects in the whole of physics. Now that might seem like an odd thing to say, but you'll get what I mean in a minute. Because the subject is space. Space, the final frontier. When I was a kid, I thought that line was probably one of the coolest things ever said on TV. If I'm honest, it hasn't lost any of its wonder over the years. The words were spoken by William Shatner as James T Kirk, captain of the Starship Enterprise. There was so much that was so cool about that line. But when I was a kid, it just meant that there was another episode of Star Trek. It used to be shown on the BBC in the 1970s when I was a kid. I genuinely don't think there are many people who haven't heard of Star Trek in some form or another. You might not be a fan, but chances are you've heard of it or one of its spin-offs. I sometimes watch the odd episode with my kids. The problem is that my kids have grown up with the special effects from the MCU. When you look back now, some of the sets were definitely a bit questionable, and some of the special effects are no longer special effects by today's standards. They're a little bit closer to Ed Wood's than George Lucas, but even so, I loved it. Even as a kid though, I had a bit of a dilemma with warp speed. I never got it. See, warp speed 1 was nice and easy. You know, it was an easy pace, but 7, 8 or even 9 was like insane speed. It was like the ludicrous plus button. If you were doing that speed, warp speed 8, you were in high speed pursuit mode. You know, the lights were flashing and you were in full on emergency dramatic music, the law. Over the years, various people have tried to figure out exactly what warp speed meant in terms of the speed of light, and a guy called Miguel Alcubierre Moya, a Mexican theoretical physicist, published a paper on the warp drive, hyperfast travel within general relativity, a theoretical means of travelling faster than light. This is the big problem, you see, the speed of light. Now, I don't think for 1 minute that Albert Einstein was a party pooper. He struck me as like an interesting dude. He did, however, suggest that nothing can travel faster than the speed of light. And to be quite honest, if this is true, it's a serious bummer. Which brings me back to this week's subject, space, the final frontier. To quote Douglas Adams, space is big. You just wouldn't believe how vastly, hugely, mind-bogglingly big it is. I mean, you might think it's a long way down the road to the chemists, but that's just peanuts to space. And this is absolutely true. It doesn't matter how good your imagination is. You can't imagine just how big space is. It just doesn't make sense. You just can't compute the size of space and the universe. I'll give you a small example of just how big space is. Get on this. The sun is huge. Seriously, it's ginormous. It's so big, in fact, that's also beyond your imagination. But fortunately for us, it's a far distance away, so it looks fairly ordinary. I mean, you look up at the sky on a light cloudy day and you can actually see the sun outlined in the clouds. What's really amazing is that it looks about the same size as the moon. I mean, this incredible coincidence, if it is a coincidence, means that every now and again we get treated to a full eclipse of the sun. Something that I'm going to have to cover in another talk, because eclipses are just incredible. I mean, they're mind-blowing. Anyway, coming back, the sun. The sun's massive, big beyond our imagination. But say we shrink the sun to say the size of a metre or a metre and a half in diameter. There's this fantastic video online that shows just how big the planets in our solar system would be in comparison to a sun of that size, and also the distance from the sun using this scale. I'll put a link below. It's only a few minutes long, but it's absolutely fantastic. It's a fantastic video, it really is. The Earth ends up the size of a small marble. I mean, this is always the case when we do a comparison with the sun. It always looks a bit small and puny, and this leads us to conclude that the Earth is small. And it is compared to the size of the sun, but the Earth is big. It's so big that we have difficulty even seeing the curvature of the Earth. And this has led some people to continue to argue that the Earth is actually flat. I mean, I've covered this subject before. Go and take a look or listen to those if you want. It's not as straightforward as you think. The Earth is the size of a marble, and it's at a distance of 40 or 50 metres or whatever from the sun. And this guy has added more planets, and the distances start to get big. The outer planets are kilometres away. Kilometres. Even with the sun shrunk to around about a metre, the planet Neptune is kilometres away. Just watch the video. It's just mind-blowing. The solar system is so big that we can do measurements on the speed of light. We can determine how long things take travelling at the speed of light. The speed of light is fast. It's the fastest thing there is, we think. Light can travel around the Earth 7 times in 1 second. 7 times. It takes about 1.25 seconds to reach the moon. The light from the sun takes about 8 minutes to reach us. Again, though, these are just numbers. I mean, we can imagine 8 minutes. We can easily set a timer on a phone to tell us when 8 minutes has passed. But from a distance point of view, we're lost. Trying to get an idea of distance when it comes to space it's too difficult. There's another video out there, and again, I've provided a link, and it shrinks the sun even further. It ends up like the size of like a grain of rice or something. And if we do this, then our planets, you can't even see them. You know what I mean? But the outer planets are not that far away. But then we compare it to the nearest star, and we suddenly go from a few meters to hundreds of miles. Now, I can walk 40 metres in, say, 20 seconds easily, brisk walk. But 200 miles is going to take me days, even if I was putting in a steady 40 miles a day, which is going some. I mean, that's a 5-day trip. But let's say I'm a bit like the Terminator, and I can keep going at a nice solid 5 miles an hour. It's going to take me 40 hours. In a really fast car, I can maybe do it in a few hours. But at the speed of light, I can do it in a fraction of a second. Here's the thing though, if I was travelling at the speed of light on the scale I've just described, to travel those 200 miles would take about 4 years. So that's about a mile a week, which is about 200 metres a day. Apologies for switching in between imperial units of miles and metric metres. I'm just feeling a bit adventurous today. But 200 metres a day, 24 hours in a day, so that's about 8 metres an hour, which comes in at about 14 centimetres a minute. And that doesn't appear very fast. In Star Trek, they're on a 5-year mission. Travelling at the speed of light, they would only get about halfway to Alpha Centauri, one of our nearest stars, before they'd have to call it a day and return to base. Now, it might be that there are loads of interesting things between Earth and Alpha Centauri, but I think it's mostly just dust and rocks and things. You know, as far as we can tell, there's not a great deal more. There's nothing out there. Between us and Alpha Centauri is mostly nothing. Now, fortunately, Star Trek got around this by having warp drive, and that allowed us to travel to various star systems and planets so that Captain Kirk and the crew could go on all kinds of like super cool adventures. My point in giving this little demonstration of space is not to sort of have a go at Star Trek and point out the flaws in Star Trek and the idea of space travel. It's to try and get some handle on the size of space. Though, as I mentioned at the beginning, really, this is pointless. I mean, let me demonstrate. The nearest star is 4.2 light years away. I can go in my garden on a clear night, look up at the sky and see the star and tell myself that I'm not actually looking at the star in real time. I'm looking at it as it was 4.2 years ago. Except I'm not, because the nearest star is Proxima Centauri and it's so far away that I can't actually see it with my naked eyes. I need a telescope. See, it turns out that the nearest star is a little on the puny side. Except, of course, it's not. It's massive. Only it's so far away that I can't see it. As I look up at the sky, I come to Betelgeuse, 650 light years away, which I can sort of get my head around. But really, that's just a trick. I mean, this trick, and it is a trick really, of converting distance into time, light years, makes the stars seem somehow closer. 650 light years seems manageable to my brain, whereas 10 to the 18 metres means nothing. Of course, 650 light years means nothing. How do you imagine a length of time greater than your own life? When I was a kid, my dad would say things like, "Man, I haven't been here in 25 years. The last time I was in Jerusalem was 30 years ago." And as a kid, I used to think, dude, that is so long ago. You are so old. How can you make a statement like that? 25 years. At the time, that was twice my life. But now I'm an oldie. I've started saying things like, "Oh, I haven't seen Fred from uni in over 30 years. I've become me dad. And my kids look at me and say, "Dude, that is so long ago. You are so old." Just in the same fashion that I used to do it back in the day with my own dad. The point of this little anecdote is that I've come to see that I can only appreciate time with regard to my own lifespan. So even 650 years is just a number. The idea of our galaxy being 40,000 light years across, or another galaxy being 2 million light years away, just makes your head spin. It's just good old honest to goodness insanity to talk about 10 million light years. It's just full on bonkers. Which led me to another thought, and it's this. Have you ever stopped to wonder where these numbers come from? How do you know the sun, the light from the sun takes 8 minutes, or that the nearest star is 4 light years away, that the neb, a star, is 1,000 light years away, that the galaxy is 40,000 light years across? We've read, or I've read, that scientists have found galaxies that are almost 13 billion light years old, which means that the light from them left 13 billion years ago, which is around the time we think the Big Bang happened. How do we know that? How do we measure such an incredibly large number? Just an aside, there's some stars out there that seem to be older than the universe. There's something called the Methuselah star. Now, I don't think this can be correct, of course, but it does highlight that there are issues when trying to calculate things this old. But I'll mention that elsewhere because it really is interesting. But coming back, 13 billion. Now, it doesn't matter if you're talking about grains of sand, dollar bills, miles, light years. 13 billion is a big number. The only time 13 billion is a small number is when we're talking about atoms, but even then it's not small. Atoms are ridiculously small, and yet if you had 13 billion laid side by side, they would stretch about a metre. But of course you wouldn't be able to see them because it would only be one atom thick, you know. I'm going to wrap this one up because next time I want to talk, I'll get into more detail about how we get these fantastic numbers. How do we know that a star is 10 light years away? Or the galaxy is 2 million or 2 billion light years away? This is what we're going to be covering next time. This is Dr. Bry, the physics guy. Hey everyone, this is Dr. Bry, the physics guy. I hope you enjoyed this episode. If you did, can you share it with your friends, your fellow students and anyone you think might be interested? That'd be great and you'd be doing me a massive favour. Subscribe now so that you don't miss out on the latest episodes and news. And check out my website right now at drbry.com. That's drbry.com. And for a limited time, I'm giving away the first part of my 7 ingredients course. It's absolutely free. There's almost 40 minutes of free video explaining the course and why you have what it takes to do physics and how it can change your life forever. And there's also a free download that you can keep. All the details are on my website. I'm also on YouTube, Instagram and Facebook, and all the details are there on drbry.com, drbry.com. I look forward to seeing you soon.